Welcome to Differentiation from First Principles. So differentiation enables us to find the gradient of a tangent to any curve at each point on the curve. So at some points we'll focus just on the actual particular point or a particular point. And to find it using the long method, which is differentiating from first principles, f dash of x, which is represents the gradient, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're going to have a look at an example. So we all know what x squared looks like. So it's a parabola, concave up, passing through 0, 0. Well, that's the vertex. We're going to find the gradient function, so the differential. And then we're going to find the gradient at particular points on that curve. So the first one's going to be the point 39, because 3 squared is 9, minus 5, 25, because minus 5 squared is 25, and 0, 0 at the vertex. And we'll look at what the gradients are at those particular points. So using the formula, f dash of x equals the limit as h approaches 0. So it was f of x plus h. So wherever there was an x, I put an x plus h. So it's x plus h all squared minus the original function, so the x squared all over h. So you expand that bracket first on top. And then you will note that the x squared minus x squared disappears. So they subtract to equal to 0. We then take a common factor of h out the front, and that then simplifies or cancels with the h on the bottom. And then we're left with the limit as h approaches 0 of 2x plus h. So as h approaches 0 and it becomes really tiny, we get 2x as our gradient function. So if our gradient function, f dash of x, is equal to 2x, then f dash of 3, so wherever there's an x we put a 3, is 6. So that means the gradient of the tangent at that point, 3, 9, is 6. At f dash of minus 5, so the gradient at minus 5, 25 is minus 10. And at our vertex, so 0, 0, the gradient of the tangent there is 0. So let's just look at one more example of differentiating from first principle, something a little bit harder. So remember, step 1 is to replace all the x's, so f of x with f of x plus h, so replace all the x's with x plus h. So we get x plus h squared minus 2 outside of x plus h minus the whole original function. So make sure you put it in brackets at the end. Expanding both of the, or expanding all of the brackets, gets you x squared plus 2xh plus h squared minus 2x minus 2h minus x squared plus 2x. On majority of occasions, when you do this, the original function disappears, so it gets subtracted away. So you're left with 2xh plus h squared minus 2h on the top. Take a common factor out again, take the h out. Simplify by cancelling out those h's. Substitute in h is 0 into 2x plus h minus 2 to give you our gradient function for this curve as 2x minus 2. Thank you.